You open your front door. Your dog is already there, tail going, body low, that full torso wag that starts at the shoulders. Sometimes before you have touched the handle, and you think, well, that is love. That is loyalty. Some deep bond between species that we do not fully understand. But here is what actually happened in the seconds before that moment. You shed roughly 36,000 skin cells every minute, dead cells coated in volatile organic compounds produced by your specific combination of genes and skin bacteria. Those molecules are light enough to become airborne the instant they leave your body, and once airborne, they follow the same fluid dynamics equations that describe hurricanes and ocean currents. They travel under doors, through ventilation gaps, down hallways. Your dog's nose, 300 million olfactory receptors compared to your 6 million, detects these molecules at concentrations of parts per trillion. You have not opened the door yet, but your atoms arrive first. When that nose finally pushes against your hand, something happens to your blood chemistry that took 15,000 years of evolution to engineer. But that comes later. First, the physics of you. Right now, as you sit there, your body is shedding somewhere between 30,000 and 40,000 dead skin cells every single minute. Charles Wechsler at Rutgers sealed people in environmental chambers with filtered air and tracked every particle a human body releases. Those cells do not simply fall. Most are small enough, between 25 and 40 micrometers, to stay suspended in air for minutes to hours, drifting on whatever currents move through the room. Every one of those cells carries passengers, volatile organic compounds, VOCs, produced by the roughly 1,000 species of bacteria living on your skin. Your skin microbiome is shaped by your MHC genes, the major histocompatibility complex, a cluster on chromosome 6 that is among the most variable in the human genome. Your specific MHC combination determines which bacteria thrive on your skin surface, and those bacteria determine which volatile compounds you release into the air around you. You see, the bacteria are the composers. Your genes set the stage. The bacteria write the music. How unique is this music? Ben DeLacy Costello and colleagues cataloged over 350 distinct volatile compounds in human skin emissions. Not 350 shared across all people, but 350 that appear in varying combinations and concentrations to create a chemical fingerprint as unique as the whorls on your thumb. No two people produce the same blend. Add the roughly 200 VOCs in every exhaled breath, acetone from fat metabolism, isoprene from cholesterol synthesis, methane from gut bacteria, and hundreds of trace organics reflecting your metabolic state at that exact moment. And the total output creates a scent plume extending 2 to 5 meters around your body in still air. In a ventilated room, much further. Try something. Rub your forearm right now. Just a light rub with your opposite hand. You launch thousands of skin cells and millions of VOC molecules into the air around you. Within 3 seconds, they spread across a sphere roughly a meter wide. Within minutes, with any ventilation at all, they reach the walls, the door, the next room. You will leave this space eventually. Your chemical signature will not. It persists for hours, sometimes days, absorbed onto furniture, carpet fibers, walls. Consider this: you are a cloud, not poetically, physically, broadcasting your identity into every space you occupy and leaving a molecular ghost of yourself behind when you go. So those molecules need to travel through a house to reach a nose. If the only mechanism were diffusion, random Brownian motion, molecules bouncing off nitrogen and oxygen in the air, the math is discouraging. The diffusion coefficient for typical skin VOCs in air is about 0.05 to 0.1 centimeters squared per second. At those rates, crossing a 5-meter living room by diffusion alone would take hours. If your dog relied on diffusion to detect your approach, it would know you were coming home sometime tomorrow. Except that is not what happens. A physicist named Brent Craven at Penn State wanted to understand how scent actually moves through real environments. He used a technique called Schlieren imaging, the same optical method that makes shock waves visible around supersonic aircraft, and pointed it at a standing human body. What he photographed was invisible to the naked eye and had never been captured this way before, a persistent column of warm air rising off the skin at roughly 0.2 meters per second. Your body runs at 37 degrees. The room sits at 21 or 22. That 15-degree temperature difference creates a thermal plume, a continuous updraft that catches your shed skin cells and VOC molecules and carries them upward and outward, far faster than diffusion ever could. Every warm-blooded human is a chimney. Your body heat pumps your scent into the room like a furnace, and the house itself, doors opening, ventilation cycling, the turbulent wake you leave behind when you walk through a corridor, distributes your molecular identity into every room. The physics that governs this turbulent transport is described by the Navier-Stokes equations, and those equations are so mathematically intractable that the question of whether they always produce smooth solutions is one of 7 unsolved Millennium Prize problems worth $1 million to whoever cracks it. So the scent rides on physics we cannot fully solve. It does not politely diffuse. It is pumped, scattered, and carried by forces that would take a supercomputer to simulate. Now, the instrument that reads all of this. 300 million olfactory receptor neurons, 50 times more than yours. But if that were the whole story, a dog's nose would simply be a bigger version of a human nose, the way a larger telescope sees fainter stars. It is not. It is a fundamentally different kind of instrument. And Brent Craven, the same physicist who photographed the human thermal plume, is the one who proved it. He had mapped one side of the equation, how the human body pumps scent into the air. Then he did something nobody expected. He turned the same cameras on the other side, the receiver. Craven pointed his Schlieren cameras and computational fluid dynamics models at a dog's nose. What he found, published in Experiments in Fluids in 2010, was remarkable. When a dog inhales, the incoming air splits into 2 separate streams, one entering each nostril independently. This is bilateral sampling. But the exhaled air does not exit back through the nostrils. It exits through small lateral slits on each side of the nose, and those exhaled jets create tiny vortices, organized whirlpools of air, that reach about 10 centimeters beyond the nose tip, actively pulling new undisturbed air toward the nostrils for the next inhalation. Let that settle for a moment. The dog is not passively waiting for scent to drift in. It is reaching out and grabbing air samples from its surroundings 5 to 10 times every second, using the physics of its own exhalation to draw fresh samples toward its receptors. Each nostril samples independently, and the brain compares concentration readings from 2 spatially separated points in real time: stereo smell, olfactory triangulation, the same principle that lets you locate a sound by comparing arrival times at your 2 ears, except with molecules instead of pressure waves. Each sniff is not a sensation. It is a precision directional measurement. How sensitive is this instrument? Genuinely staggering. When a single VOC molecule lands on an olfactory receptor protein, it triggers a signaling cascade that amplifies the signal roughly 1,000-fold before it reaches the brain's olfactory bulb, which, in a dog, is proportionally 40 times larger than yours. In 2022, researchers at Queen's University Belfast demonstrated that dogs reliably detect the human stress hormone cortisol at concentrations below what a $250,000 gas chromatography mass spectrometer can reliably measure. The dog outperforms the machine, 1 to 2 parts per trillion. Now, let me make that number tangible. If you dissolve 1 drop of a substance in 20 Olympic-sized swimming pools, a trained dog could find it. Not in theory. Repeatedly, in controlled double-blind experiments where even the handler does not know which sample is correct. Let me put that differently. A single Olympic pool holds 2.5 million liters. 20 pools, 50 million liters, 1 drop, and the dog identifies it, not guesses. Identifies. With a success rate that meets the evidentiary standards of criminal courts, dogs' scent identifications are admitted as evidence in multiple countries. The biological instrument in your dog's face holds up in court against a $250,000 machine. When you put both halves of Craven's work together, something clicks. The same physicist, using the same Schlieren imaging technique, mapped the human side, the thermal plume pumping scent molecules into the air, And the dog side, the bilateral aerodynamic sampler grabbing those molecules from the environment at 5 to 10 hertz. One researcher, two sides of a single system. The human broadcasts, the dog receives. Fluid dynamics connects them. Back to the front door. Consider what this means. The scent plume? VOC molecules riding on dead skin cells, carried upward by your thermal plume, distributed through the house by pressure gradients and turbulent mixing, entered the building through the gap under the door, the mail slot, the ventilation returns. Molecules that left your skin 30 minutes ago traveled through corridors and around corners. Your dog detected them at parts per trillion and identified your specific MHC-determined chemical fingerprint. Not a human. You. Before you reached the front steps. But there is something stranger about the timing. Your dog was already at the door before your fresh outdoor scent arrived. It was waiting. It was anticipating. And the explanation for this is thermodynamics. Alexandra Horowitz, a cognitive scientist at Barnard College, had spent years studying how dogs experience the world through scent when she proposed something elegant. When you leave for work in the morning, your scent fills the house. On the couch, in the hallway air, on the kitchen counter. But the moment you walk out, that scent begins to decay. VOC molecules evaporate from surfaces at rates governed by their vapor pressure. They oxidize, reacting with ozone and hydroxyl radicals in the indoor air. They dilute as the ventilation system circulates fresh air through the rooms. This decay follows a predictable thermodynamic curve. Exponential decline governed by each compound's volatility and the building's ventilation rate. It has experienced this curve every single workday, hundreds of repetitions. Your scent at 8 in the morning when you leave is strong. By noon, substantially weaker. By 3 in the afternoon, weaker still. By 5, when you normally walk through the door, it has faded to a specific threshold that the dog has learned to associate with your imminent return. Your dog does not know what 5 o'clock means, but it knows what your scent smells like at 5 o'clock because it has calibrated this chemical clock against your arrival day after day for years. The fading of your scent is a countdown, and the dog reads the countdown with a biological instrument that resolves parts per trillion. The dog is not psychic. It is reading a thermodynamic decay curve. The clock is your fading molecular ghost. Now, here is where this story changes direction. Because everything so far has been one-directional, the dog reading you, decoding your chemistry, tracking your schedule through the physics of scent decay. I want to tell you what happens in the other direction, what the dog does to your body, to your blood, to your heart. A research group at Asabu University in Japan decided to measure something no one had thought to measure before. They brought dog owners into a lab, they drew blood, then they asked the owners to do nothing except sit with their dogs and let the dogs look at them. Just sustained mutual gazing, no commands, no treats, no tasks. After 30 minutes, they drew blood again and measured oxytocin, the neuropeptide involved in bonding, trust, attachment. What they found was extraordinary enough to be published in Science in 2015. When a dog and its owner gaze at each other, oxytocin rises in both. Not in one species watching the other, in both simultaneously. The longer the mutual gaze, the higher the spike in both bloodstreams. They ran a control, and this is the part that matters. Wolves raised by humans from birth. Hand-fed, socialized, living with their caretakers. The wolves did not sustain mutual gaze, and their owner's oxytocin did not rise. This specific feedback loop, mutual gaze driving oxytocin release in both parties, was previously known in exactly one context in all of mammalian biology, between a mother and her nursing infant. The same molecule, the same brain circuits, the same self-reinforcing positive feedback architecture. Dog gazes at owner. Owner's oxytocin rises. Owner feels warmth. An involuntary neurochemical response, not a choice. Owner reaches out and touches the dog. Dog's oxytocin rises. Dog gazes more. The loop tightens. Dogs are the only non-primate species on Earth that activates it. That is worth sitting with. Your dog triggers the deepest bonding machinery mammals possess, the neurochemistry of parental attachment, across a species boundary. Not cats, not horses, not any of the dozens of animals humans have domesticated over 10,000 years, only dogs. Physical contact amplifies it further. 15 minutes of petting a dog drops cortisol by 10 to 15% and increases heart rate variability, a clinical sign that the parasympathetic nervous system has taken over from fight or flight. Your heart slows. Your breathing deepens. Your body shifts measurably from the biochemistry of threat to the biochemistry of safety. The moment at the door is not comfort as metaphor. It is pharmacology triggered by proximity to an animal that evolution spent millennia engineering to produce exactly this response. You see, this is how evolution works sometimes, not through competition, through chemistry. Dogs are the only non-primate species that spontaneously seeks eye contact with humans. Wolves do not do this. Even wolves, hand-raised from birth, bottle-fed, socialized from their first week of life, sleeping in human beds. They still do not look into a human face the way a dog does. In wolf social behavior, sustained eye contact is a threat. Something changed in the domestication of dogs that reversed this instinct entirely. Mutations in the oxytocin receptor gene and the melanocortin 2 receptor gene that make dogs hypersociable in ways their wolf ancestors are not. These are not learned behaviors trained into individual animals. These are genetic changes fixed into the species. Here is what happened. Over 15,000 to 40,000 years, the wolves that hung around human settlements, scavenging, tolerating proximity, varied in their willingness to approach people. Some were bold, some were fearful. But the ones that happened to look at human faces, that held a gaze even briefly, triggered something in the humans. Oxytocin. Warmth. The parental bonding response. Those wolves got more food scraps, more tolerance, more shelter. They survived harsh winters that killed the gaze averters. They bred. Their offspring looked at human faces a little more. And generation after generation, over thousands of years, selection pressure pushed a predator into something unprecedented. A pharmacological symbiont, an animal that alters human endocrine function through eye contact and physical touch. Nobody planned this. No human decided to breed wolves for eye contact. It happened because the wolves that accidentally activated human bonding chemistry were the ones that lived. Evolution does not need intention. It needs differential survival. Sit with that for a moment. 40,000 years of accidents, of wolves that happened to hold a gaze a second longer, produced an animal that rewrites your blood chemistry when it looks at you. Your dog did not learn to love you. Thousands of generations of selection wired it to trigger your bonding chemistry, and wired you through the same coevolutionary pressure to respond. There is one more thing, and it is, I think, the strangest of all. The chemical identity your dog reads at the front door, your VOC fingerprint, carries more information than your genome. In 2011, Ludwig Pintz and colleagues tested whether trained, scent discrimination dogs could distinguish between identical twins, monozygotic twins, people who share the exact same DNA sequence in every cell of their bodies. The twins lived in different households, ate different diets, worked different jobs. The dogs distinguished them perfectly. Every single trial. No errors. No hesitation. That scent is not written by your genes alone. It is an emergent property. Your MHC genes shape which bacteria colonize your skin, and those bacteria produce your VOC signature. But the microbiome itself changes with everything you do. Your diet, your sleep, your stress levels, the people you live with, the medications you take. Two identical genomes exposed to two different lives produce two distinguishable molecular signatures, because different life histories cultivate different bacterial communities which compose different chemical music. What does this mean in practice? The information content of your scent plume exceeds what is encoded in your 3.2 billion base pairs of DNA. Your genetic code could not tell those twins apart. Your dog's nose could. Every time. Nobody fully understands how dogs store and retrieve these signatures. How a brain encodes a chemical identity built from hundreds of compounds at parts, per trillion concentrations. We do not know. Not yet. What we do know is that your dog reads this signal in real time and it updates continuously. When you are sick, your VOC profile shifts. Tumors hijack cellular metabolism and produce unusual byproducts, which is why dogs detect lung cancer, breast cancer, and bladder cancer through changes in exhaled breath. Diabetics emit altered acetone ratios as blood sugar drops. Epileptic seizures produce detectable VOC changes minutes before onset, enough warning for the person to reach safety. Every one of those detections is the same physics, the same bilateral sampling, the same parts, per trillion sensitivity, the same fluid dynamics that brought your scent under the front door, not just a cloud. A broadcast station transmitting a real-time molecular status report. Identity, health, emotional state, metabolic activity, and your dog reads the transmission the way you read emotion in someone's eyes. Instantly, effortlessly, with a resolution no instrument we have ever built can match. The front door, one last time. But this time, you know what is happening. You walk in shedding 36,000 cells per minute, exhaling 200 volatile compounds per breath, broadcasting cortisol and adrenaline from your workday through your skin, in concentrations you cannot smell, but that registered on 300 million receptor neurons before your key entered the lock. The thermal plume from your body, that invisible chimney Craven photographed, carried your molecules ahead of you through the ventilation system. The house has been telling your dog about your approach through fluid dynamics for the past 30 minutes. It read the thermodynamic countdown of your fading indoor scent and started waiting 20 minutes ago. It confirmed your fresh arrival signature through bilateral molecular sampling at 5 to 10 Hz. Each sniff a directional measurement, each nostril an independent channel converging on a single identification, you. It knows you are tired before you do. It knows you are stressed before you feel it consciously. It read your cortisol levels in the first sniff, your metabolic fatigue in the second, your emotional state in the third. 3 measurements that took less than a second, performed by an instrument that outperforms a $250,000 machine. And then it pushes its head against your hand. Your cortisol drops, your oxytocin spikes, your heart rate slows, your vagus nerve fires. Because 15,000 years of coevolution, a wolf that learned to look into a human face, and a human that could not help but respond, engineered precisely this moment. A feedback loop older than language, older than civilization, older than agriculture. Bonding chemistry hijacked across a species boundary by an animal that evolution built to change your blood. That is not loyalty. That is fluid dynamics, thermodynamics, and organic chemistry, and your dog reads it the way you read a face.